Hello guys, good morning. Today I'll be explaining the math AMS quiz of term 1 week 9. So just in advance, it's a really easy quiz. So if you want, it's a really beneficial way to increase your marks because it's one of the easiest quizzes so far, Also, I'm sorry if I'm a little sleepy because I just woke up, by the way. Okay. So fill in each blank with an integer. We have f10. Whenever we see something like this, f10, that means it's gonna be f, and inside f we're gonna put the f of 10, or the 10 of f, So anytime you see something like this, it means what it means, f brackets f10. Okay, that means first we're gonna find f10, then we are gonna place it again in f. So the function f is here. That means if we're gonna find f10, we're gonna replace x by 10. So now it becomes f dot x. This means what? This means fx, by the way. Same thing, okay? It is gonna give us 2, and we said every x we're gonna replace it by 10. 2 times 10 plus 1. So now fx is gonna be 21. So that means if we replaced 10 inside of f, we will get 21. But now we need to replace what? We need to replace the f of 10 inside f again. So now what's happening? We're replacing 21 over here. So every x, we will replace it by 21. So now it became f10, okay, gives us 2 times 21, okay, plus 1. If you can do it mentally, you can do it on the calculator. 2 times 21 is 42. Plus 1, we will get 43. So again, to find f of 10, first thing we're gonna find f of 10. How do you find it? You replace 10 inside every x in the function f. After that, whatever value you are gonna get, we are gonna replace it inside f again. So the result we got from f of 10, we're gonna replace it in f again. So now every x we will replace it by our result, and then we will get the answer of f of 10. Question: f inverse x. This is always x. I believe that your teachers told you, okay? Whenever you see f of inverse of x, of f inverse x, or f inverse of fx, this is equal to what? It is equal to x. Okay, so for example, just like a random example, if we were to do f inverse 10 directly without thinking, if they asked you without proving why, you would directly put that the answer is 10. Okay, anytime you have f and then the inverse of the function, so f inverse and then a number or x, it's always gonna be either the number or x. Okay, so over here our answer is 43. Now g, 3x plus 1. We're gonna search for function g. This is function g. They need us to have g, 3x plus 1, knowing that the function is x squared plus 3. That means every x we're gonna replace it by 3x plus 1. So now g 3x plus 1 is equal to 3x plus 1 squared plus 3. This becomes 9x squared plus 6x plus 1 plus 3. So then the final answer is 9x squared plus 6x plus 4. So the answer here is 9, 6, and 4. Now f of inverse 57. This is a nice question. I don't think it's come across before, but it's a very nice question. F of inverse. If you remember, they would give us f, for example. What's the f here? Here we know that fx is equal to 2x plus 1. And they would ask us to find what f inverse. Or to find f inverse, we would do what? We would change this to y. So now y is equal to 2x plus 1, And then we would have to leave x alone, if you remember how to do this. And then in the end, we would substitute what? We would substitute the inverse function numbers. I don't know what it is. I'm just gonna put 42, okay? F of inverse 42, we were gonna substitute it in the y. We would do something like this. Well, instead of doing all of this tricky and long method, it's gonna be a tricky and long method. Just simply do this. We have fx is equal to, so fx is equal to 2x plus 1, okay? We have f of inverse. Usually, when we have fx, for example, we would replace x. Now, if you have f inverse, you will do what? Replace fx. Okay, so now from now on, make it a rule. Anytime you see f inverse and inside the brackets a number, then you replace it directly. You replace it directly in the fx. What does it mean? The function is fx is equal to 2x plus 1. Okay? We said anytime we have f of inverse and a number inside of the brackets, we are gonna replace it inside instead of fx. So that means what now? That means 57 is equal to 2x plus 1. Move 1 to the other side. 57 minus 1 is 56. So 56 is equal to 2x. Let's do 56 divided by 2. It is then 28. So x is equal to 28. Very simple, very easy. Okay? So, look. Anytime you see f inverse and a number in the brackets, just replace it instead of the fx. Okay? However, every time you see fx, you have to replace the number here instead of x. Okay? Now, this one is very, very nice. Fx equals 17 for x equals this. Look, pay attention really closely. We have fx, we don't have a number inside of the brackets, but it's equal to 17. Whenever we have something like this, we're gonna put the whole function equal to this number. So what's the function fx? The function fx is 2x plus 1. But then we also have that fx is equal to 17. It's like, substituting. So you put this instead of this because they are equal. So now you will get what? You will get 17 is equal to 2x plus 1. Bring 1 to the other side. You will get 16 is equal to 2x, and then x is equal to 8. So again, we have fx is equal to 17. What we're going to do, we're going to write the function fx is equal to 2x plus 1, and then we're going to substitute. We have fx is equal to 17, then we substitute 17 is equal to 2x plus 1, and we solve, and then we will get 8. Now here, of course, in this AMS, we're allowed to use calculators. However, in the periodic, we're not allowed to, okay? So to 3 significant figures, h 0.8. Let us go up. hx is 3 to the power of x. So if we have hx is equal to 3 to the power of x, and they gave us that the function is h 0.8, that means we're gonna have to replace every x by 0.8. So it's 3 to the power of 0.8. So if we do it on the calculator, 3 to the power of 0.8, we will get 2.4082, but they needed 3 significant figures, so that means we're going to take 1, 2, 3. We can round it, so then it will become 2.41. So here the answer is 2.41. This is something new, okay? Whenever you see hx equals to 187 and your my bad, wait. hx, first of all, is equal to 3 to the power of x. Whenever they give you that the function is equal to a number and you have your function is a power, okay? Whenever your function is in this format, you're gonna use this equation. Simply, you're gonna do log number over log base. What do we mean by log number? On the calculator, you will see that there is something called log, okay? You will click on it, it will open one part of the bracket. Now you put the number. Which number? You put this number that the function x is equal to. So you put 2187, okay? Then you put it over log the base. What is the base? The base is 3 and the exponent is x. So like this, we're gonna find what? We are gonna find the exponent x. So it's gonna be log 2187 over log 3, and we will get 7. So our answer is 7. And if you want to double check, you can do 3 to the power of 7 and you will get 2187. Now, question number 2. Very important. I'll write some rules for you. Always remember this phrase. So, katoa. Okay? So, katoa. We have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, you can either use it as opposite over adjacent, or you can do sine over cosine. Okay? So tangent is both of these. So again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, or sine over cosine. Okay? Then we have what? We have the secant, cosecant, and cotangent. Secant is very simply 1 over the cosine. Cosecant is very simply 1 over the sine. And cotangent is very simply 1 over the tangent. So if you guys want to remember, please write these down. It's very, very important. So let's start. What is the value of tan angle? This means angle. Whenever you see something that looks like a 0 and it's crossed in the middle, it means angle. What is the value of tan of the angle if cosine of our angle is 15 over 17 and sine of our angle is 8 over 17? Very simply, we know that we're going to use tan, cosine, and sine. So whenever we have tan, cosine, and sine, we can use so, ka, toa. Okay? So to find tangent, this is what we need to find. We can either do opposite over adjacent or sine over cosine. So here we can easily do sine over cosine because we are given the value of the sine and we are given the value of the cosine. So it's gonna be, if you're gonna do it on your calculator, put the brackets, 8 over 17 divided by 15 over 17. And then if you do it on your calculator or mentally, however you like to do it, you will get 8 over 15. So our answer is 8 over 15. Question number 3. Here we have what? We have cosecant. Remember, we have secant, I will abbreviate it. Secant is 1 over the cosine. Cosecant is 1 over the sine. And cotangent is 1 over the tangent. Okay? So they're asking us for the value of the cosine if we have that, the value of the cosecant, if we have that our cosine is 15 over 17 and our sine is 8 over 17. Very simply, we know that cosecant is 1 over the sine. So we have our sine, and to find the cosecant, it is going to be 1 over 8 over 17, and you will get 17 over 8. If you want to make it a rule, you can directly say anytime you see cosecant and you are given the sign, just flip it. Flip the sign upside down. So 8 over 17, flip it upside down, it becomes 17 over 8. So our answer over here is 17 over 8. Question number 4. They're asking us for the secant we know that the secant is 1 over the cosine. Okay, if we are given the cosine and the sine, whenever we have secant, we're going to do 1 over the cosine. So here it's going to be 1 over 15 divided by 17, and then you will get what? 17 over 15. So then you can make it a rule. Anytime you see secant and you are given the cosine, you can flip the cosine. So it will be opposite. If it's 15 over 17, then it will be 17 over 15. So our answer for number 4 is 17 over 15. Now, question number 5. We are given, oh, this is a nice question. We are given cotangent. We know cotangent is 1 over the tangent. But do you see the tangent anywhere here? No, we have to find it. We know tangent is what? Tangent is either opposite over adjacent or sine over cosine. Are we given opposite and adjacent? No, but we are given sine and cosine. So we can do sine, which is 8 over 17, divided by the cosine, which is 15 over 17, and we will get the tangent, which is 8 over 15. But is this what we need? No, we need the cotangent. So to find the cotangent, it's going to be 1 over the tangent. So 1 over 8 over 15, and you will get what? 15 over 8. So very simply, anytime you see cotangent, just flip the tangent upside down. So our answer is 15 over 8. Question number 6. This is a nice question. When we convert from radian to degrees, okay, we multiply by 180 over pi. So remember, anytime we're going from radian to degrees, we are going to multiply by 180 over pi. So if we have 2 pi radians, okay, how many degrees it is? We are going to leave the radians alone, and we're going to leave the degrees alone because these are units, okay? And then we're going to take this 2 pi, and we're going to multiply it by 180 over pi, okay? The pi will cancel with the pi, and then we're left with 2 times 180, which is 360. So now we know that 2 pi radians is 360 degrees. We can make it a rule that pi radians is 180 degrees. And 2 pi radians is 360 degrees, okay? So pi radian 180 degrees to pi radians 360 degrees. From radians to degrees, we're gonna multiply by 180 over pi. Now question number 7. We're also changing from radian to degrees. So we're gonna multiply the value by 180 over pi. The pi will cancel with the pi. So now we are left with 5 over 6 multiplied by 180. You can do it on the calculator. And you are gonna get 150 degrees. So 5 over 6 pi radians is equal to 150 degrees. Question number 8. Oh, this is nice. We are changing now from degrees to radians. We know from changing from radians to degrees, we multiply by 180 over pi. But here, we're gonna do something different. We're gonna flip the fraction. So now, when we're going from degrees to radians, we're gonna multiply by pi over what? Over 180. So, from radians to degrees, we multiply by 180 over pi, and from degrees to radians, we multiply by pi over 180. So we have 40 degrees, we need to change it into radians. So we're gonna do 40 times pi over 180 is equal to radians. Okay, you can do it on the calculator. First of all, it will become 40 over 180. Cancel out 40 and 180. You can do it on the calculator. You will get 2 over 9. So it becomes 2 over 9 pi. They're asking for the value of the question mark. We have 9, we have pi, so definitely the question mark is 2. Question number 9. Again, to change from radians to degrees, we are going to multiply by 180 over pi. So 2 over 3. First of all, the pi will cancel with the pi. Then 2 over 3 times 180, we will get 120. So 2 over 3 pi multiplied by 180 over pi. This gives us what? 120. So our answer here is 120 degrees. Question number 10. Very nice. What is the value of m if cotangent is 27 degrees and tangent m tangent m degrees and m is between 0 and 9? Okay, I will explain a way that seems more logical. It's similar to something we did last year in physics, okay? But this way might seem more logical and it might help you understand. Then from this way, we are gonna derive a constant rule, okay? So, first of all, we know that cotangent is what? It is 1 over the tangent, okay? So if we have the cotangent, how can we possibly find the tangent? Okay, so we have that cotangent of 27. Cotangent of 27 means 1 over the tangent of 27, okay? Then it has to be equal to the tangent of an angle M. First thing you're gonna do is that you're gonna put on the calculator 1 over the tangent of what? Of 27. And now you got 1.9626 whatever is equal to tangent of m degrees. If you remember from last year, if we have the value and we need to find the angle, what do? Basically, if we move tangent to the other side, it will become inverse of tangent. So tangent inverse, we put 19626, etc. It will be equal to the measure of the angle. Again, I will repeat. We found what? We found that 1 over tangent 27 is 1.962926, okay? And it is equal to the tangent of the angle. To find now the angle, we're going to move tangent to the other side. So if on this side it is tangent, on the other side it becomes inverse of tangent, okay? It doesn't become over tangent, no. If it's on this side tangent, on the other side it becomes inverse of tangent. So you're going to do shift and tangent and you're going to put the answer inside and you will get that the angle M is 63 degrees. طيب, I have a question. What happens if we do 90 minus 27? 90 minus 27 will also give us 63. So instead of doing this big long way over here, we can directly do 90 minus 27. Why? Because they are related. Cotangent and tangent are related. So to find the tangent from the cotangent, we can easily do 90 minus 27, and then we get 63. Question number 11. Very nice. They are asking us for the cosine of the angle. Remember, so, ka, to. So we are looking for what? We're looking for the cosine of this angle. And we know cosine is adjacent over hypotenuse. We have the adjacent to the angle, which is 40. Adjacent means the side next to it. And then we have the hypotenuse, which is 41. So very simply, to find the cosine of this angle, it's going to be 40 over 41. Done. You see how simple it is? Once you have the tricks and the ways, you can find it really easily. So our answer is 40 over 41. Now, question number 12. Oh, this is very important. You have cosine 26, okay? then you have sine degrees, and you have sine 49 and cosine degrees. We need to find the sine and the cosine, knowing that this is equal to this and this is equal to this. Very simply, and there is a really easy way to do this, because when we are talking of sine, cosine, tangent, okay, there always has to be one angle that is 90 degrees. So if we're given one of the angles, okay, if we are given one of the angles, then we definitely can find the other one. We can do 90 minus 26 is equal to 64. So the first sine is 64. Now the second cosine is 90 degrees minus 49, sorry. So 90 minus 49, we will get 41. So it's sine 64 and cosine 41. Now question number 13. They need the value of what? Cosine A. They told us, given ABC is right. Okay, whenever they give us a triangle, always the middle angle, which is over here, is the vertex, that is the right angle. That means this is our right triangle, okay? Over here is the right angle. We have triangle ABC, that means the right angle is at B. And then you can put A here and C here, or the opposite way, however you want, okay? So this is how we deal with the right triangles. They told us AB is 11 centimeters, then BC is 60 centimeters, and AC is 61 centimeters. They are asking us for the value of the cosine of A. So we're gonna take A, and we know that cosine is adjacent over hypotenuse, okay? According to SOHCAHTOA. Okay, it is adjacent over hypotenuse. What is the adjacent of A? It is 11 centimeters over the hypotenuse, which is 61. So very simply, the value of the cosine of A is 11 over 61. Question number 14. It's the same triangle, the very same triangle. Here is B, here is A, here is C, here is 11, here is 60, here is 61. Now they need the value of sine A. We know sine is what? Sine is opposite over hypotenuse according to SOHCAHTOA, okay? The opposite of A is 60 and the hypotenuse is 61. So very simply, the sine of A is 60 over 61. Question number 15. Given triangle ABC is right with AB equal to 11, BC equal to 60, and AC equal to 61. As a fraction in lowest terms, what is the value of tangent of A? So again, it is the same right triangle that I'm not seeming to be able to draw. Okay, so it's the same right triangle with the vertex B. Let us switch it up this time, you know? Just to show you how you can put it here and you can put it here. So AB is 11, BC is 60, and AC is 61. Now they need the tangent of A. We know tangent is what? Tangent is opposite over hypotenuse. So you can either do that or you can do sine over cosine. Definitely doing sine over cosine is longer. So tangent will be what? The opposite of A, which is 60, over the hypotenuse of A, which is 11. So it is 60 over 11. Now, question number 16. The number of hours that a group of 42 grade 10 students spent using a computer in a day were summarized in the histogram below. Complete the frequency table below. Whenever we have a frequency table, we should also include what? The width. So when we're having a histogram or something like this, like this is a histogram, we should have the frequency, the width, and the frequency density. Three things that we need whenever we have a histogram. So here we need to find what? We need to find the frequency. How can we find the frequency if they gave us the frequency density? Very simply, the first thing we're gonna do is find the width. How do we find the width? We're gonna go down and we're gonna go to the hours. We're gonna do, for example, 4 hours minus 0 hours, 4 hours. 6 minus 4, 2 hours. 8 minus 6, 2 hours. 9 minus 8, 1 hour. And 10 minus 9 is 1 hour. So now we have found what? We have found the width. Okay? Using the width, we can use the equation, which is that frequency density is equal to the frequency over the width. So if we have frequency density given and we have the width given, can we find the frequency? Definitely yes. So let's go up and see. Frequency density is equal to frequency over width. So we know that the width was, I believe, 42211, if I'm not mistaken. So let's put it actually in the histogram. So the width of this one is 4, the width of this one is 2, of this one is 2, of this one is 1, and this one is 1. The frequency density of the first one is 2. So 2 is equal to the frequency over the width, which is 4. So definitely the frequency is gonna be 2 times 4, so then the frequency is 8. We got the first frequency, which is 8. Now, second frequency. Again, we are gonna do frequency density, which is 6. It's equal to the frequency over the width, which is 2. So frequency is equal to 6 times 2, so it is 12. Now, the third frequency. We know that frequency density is equal to frequency over width. The frequency density is 8. It's equal to the frequency over the width, which is 2. So frequency is equal to 8 times 2, which is 16. Now the fourth frequency. We have that the frequency density is 4. Okay? The frequency we need to find and the width is 2. Sorry, my bad. And the width is 1. Okay, pay attention. Don't misread and do silly mistakes like me. Okay? So we have the frequency density, we have the width, we only need to find the frequency. So to do that, we're gonna do 4 times 1, which is 4. It's equal to the frequency. So basically, the fourth frequency is 4. Now finally, we are left with what? We are left with this one over here, which is the final frequency. We are gonna do then the frequency distance. Oh my goodness, I made a new word. The frequency distance. Oh my goodness. The frequency density. My bad. I apologize because I'm still like, I just woke up, so I really apologize. Anyways, the frequency density, which is 2, it is equal to the frequency over the width, which is 1. So now we're gonna multiply 1 and 2. You're gonna get that the frequency is 2. So in order, it's 8, 12, 16, 4, and 2. But look, they told us what is the number of students. It's 42 grade 10 students. So let's add all the frequencies together. 8 plus 12 plus 16 plus 4 plus 2, and we will get then 42. So if you want to check if your frequencies are correct, you add them all and they should be equal to the total, which is 42. So let's remember this order: 8, 12, 16, 4, 2. And here we're going to put 8, 12, 16, 4, and 2. So let's submit, and inshallah there is no mistakes. Alhamdulillah, thank God there are no mistakes. Thank you guys for watching. I hope you had a wonderful day, and yeah, have a wonderful day.